In this video, we're going to look at example 1 in section 4.4. All right, this is where the real fun begins with integral calculus. So we are going to be able to calculate the integral from 0 to 1 of 2x dx. So before we do that, let's just get a sense of what we are actually computing here. So if we look at the curve 2x, what does that look like? Well, we just have 2x. If we had a function y equals 2x, it's just a line going through the origin, where if we rise 2, slope of 2, so if we rise 2, go over 1, we can plot our line. So our line looks something like this. So now we want to compute the integral of this function from 0 to 1. So that means we want to compute the area under this curve. Okay, we see that this image we get is a triangle, so we could just actually compute the area. Why don't we just do that first? Okay, so height of 2, base of 1. So we'd have 1/2 base times height, which would give us 1. So the area is 1 here. But let's see if we can compute this integral using the fundamental theorem of calculus. All right, so the fundamental theorem tells us that this integral from 0 to 1 of 2x dx is equal to big F of 1 minus big F of 0, where what is big F? Big F is the antiderivative of little f, which means that if we take the derivative of f, we get little f. So what function could big F be? What function is such that when we take the derivative of it, we get 2x? Awesome. You might be thinking about the function x squared. Well, let's take a look and see. So we're going to check. And we can think about x squared because we know we need a 2 in front of the x. And using exponents, the power comes down. We erase 1 from the power. So let's check if big F equals x squared is an antiderivative of 2x. Okay, and you might be ahead of me by now. So x squared prime, we remember our derivative rules, does become 2x. So yep. One side note here is I always say an antiderivative, not the antiderivative. That's because there are many antiderivatives of one function. We found one here, but let's look at the function instead, x squared plus 7. If we take the derivative of x squared plus 7, what do we get? 2x plus the derivative of 7 is 0. So we also get 2x. So it turns out that a general antiderivative for 2x would look like x squared plus any constant we want to add there. But for actually computing the integral, it doesn't matter what constant we put there. So the easiest thing to use is just x squared. Okay, so we found the antiderivative of 2x. So I'm going to erase to give myself a little bit more room. So now we know that this integral from 0 to 1 of 2x dx is equal to x squared evaluated at 1 minus x squared evaluated at 0, which when we compute that out, 1 squared is 1, 0 squared is 0, so we get 1, which is what we found from the graph also. All right, so we're going to do a little bit more of these. They're going to start to be a little bit more challenging, but it's really important to have a good sense of some of these basic integrals to get us started and to get us comfortable with computing antiderivatives.